Alright, so let's get started with 6.2, the law of cosine. So 6.1 gave us the law of sine, 6.2 gives us the law of cosine. So here it is in three different forms, but what we're looking for here is, just remember the pattern, a squared, on the other side you've got b squared and c squared, minus 2bc cosine a. So if you'll notice this, whatever side you have on the left side of your equals, that's going to be the angle that you're doing the cosine of on the other side. So if you have b squared over here, cosine b over here. C squared over here, cosine c over here. And then the other letters are going to be everything else. So if you're using c on the left, a and b on the right. If you're using b over here, a and c on the right. Okay? This alternative form is nice if you want to memorize that. You can just get it from solving from here with one extra step. But if you get cosine by itself, that can be helpful in a number of cases. So don't have to, but it could be a little bit of a time saver. So let's go ahead and use this law of cosines in a few examples here. We're going to solve the three angles of this triangle. We know the sides, we want the angles. Okay? All right. So it's usually helpful to figure out the largest angle first. And that's true for a couple of reasons, which we might discuss if we see some examples. But for right now, just take my word for it, we're going to find the biggest angle first. So let's do that. That angle is going to be side B, or angle B, because side B is the largest side. So if we have b squared, then the other side is a squared plus c squared minus 2a c cosine b. Is that right? We know b squared over here. B is 19. All right, so to the calculator we go. And what do we have here? We've got 19 squared minus 8 squared, which is 64, minus the 14 squared, just moving things over to the other side. 101, and then I'm going to divide by 2 times 8 times 14. And, oops, should have divided by a negative there. So let me times by -1 so we can put a negative on it. All right, so we have negative 0.45, and that's going to equal the cosine of b. So at this point, we've gotten cosine b by itself, and that equals negative 0.45. All right, so we want cosine by itself, so we'll do the inverse cosine. Negative 0.45089. And so we get 116.8 degrees. 116.8 degrees for B. Okay, so I'm going to go ahead and do that one more time for another angle. Now we'll get the second largest angle here. So let's get 14 over here. And we'll do that by itself. 14 squared equals the other angles. Same thing here. 8 squared plus 19 squared minus 2 times 8 times 19 cosine of C. So we're finding for C now. Back to the calculator we go. And so we'll start with 14 squared minus 8 squared minus 19 squared divided by negative 2 times 8 times 19. And we get 0.75, and we need to do the inverse cosine of that. 0.753289, and we get 41 degrees. And luckily, sorry, what was that with the decimal place? 41.1 degrees. Luckily, we don't have to do any more law of cosines, because at this point, we can do 180 minus 116.8 and get 63.2, and then we can subtract 41.1 and get, what do we got here? 1, 2, and 2. 22.1 degrees for the third side. Oops, I labeled those in the wrong places, didn't I? Switch places. We solved for C. And what do we have here? 41.1 and 22.1. And the reason actually that I realized I made that mistake is because 8 is the smallest side, so angle A needs to be the smallest angle, right? So they're going to line up. The sides will dictate the sizes of the angles. All right? So let's see if you can do the same sort of process for problem 5. All right, let's do the same thing here. We got the remaining angles and the missing side here. So let's go ahead and figure out the missing side first. So a squared equals 9 squared plus 12 squared minus 2, 9 times 12, cos of 25. To the calculator we go. 9 squared is 81, plus 12 squared is 144, minus 2 times 9 times 12 times the cosine of 25 degrees. And we get 29.24. So we'll round that off to just 29.2. Alright, and now we got to go in and find one more angle. And let's go ahead and solve for angle C. So on this one we're going to have 12 squared equals 9 squared plus 29.2 squared minus 2, 29.2 cosine of C is what we're looking for here. To the calculator, let's plug it in. And so we started with 12 squared on the other side. Oh, I don't need to do that. 144 minus 81 minus 29.2. I'm going to put in a couple extra decimal places in here. 237518 squared divided by negative 2 times 9 times 29.2. And so we'll do the inverse cosine of that. And this is going to get us an error, actually, because the cosine can't be bigger than 1. Let's see if I made a mistake here. What do we got here? 144 minus 81. And that squared is going to be large. And so that divided by 2 times 29 looks pretty good. Let me pause this for a second and see if I can find my error. Alright, got it. I made a silly mistake right here. A squared is 29.2. I forgot to square root. Forgot to square root, so let's grab the calculator. Square root of 29.2. $5.4 was my mistake there. Square root of 29.2 is going to be 5.4. So now we'll go back in here. It's not 29.2, it's 5.4 squared, and it's not 29.2, it's 5.4 right there. So we needed to square root. All right, now we go back to the calculator. Let's get some correct answers here. This is a 12 on the left side, so that's 144 minus the 81 minus 5.4 squared, 33.8. And now let's divide that by negative 2 times 9 times 5.4. Oh. Oh, 5.4, not 5, negative 4. Negative 0.348, inverse cosine of that. And we get 110 degrees. So 110 degrees for, what were we solving for here? That was angle C. We said 104? 110. All right, 110 degrees up here. And then subtracting from 180. 180 minus 110 is 70. minus 20 is 50, minus 5 more would get 45 degrees in that bottom corner. Okay? All right, so see if you can do this for exercise 7. Don't make the mistake I did and forget to do the square root. And see if you can find all the missing pieces on problem 7. All right, same exact situation, except now we got a word problem. So we got the softball diamond here, 43 feet from home plate to the pitcher's mound, 60 feet from home plate to first base, 45-degree angle right here. Let's figure out h, the distance from the pitcher's mound to first base. All right, so we're doing law of cosines here, so we want h. H squared is going to be the other side squared, added together. So 43 squared plus 60 squared minus 2 times those angles, or sorry, times those sides. Cosine of the angle, which is 45. And plug it in. So we've got 43 squared plus 60 squared minus 2. Put that in parentheses just to make sure. It should get it with order of operations, but just to be certain. And we have 1800 equals h squared, so let's do the square root of that. And 42.43 feet is going to be the distance from the pitcher's mound to first base. So pretty close to 43 here, but not exactly the same distance. See if you can use the same type of thinking for problem 43. All right, now let's talk about bearing here. So this ship travels 60 miles due east from A to B. Then it swings north a little bit and goes from B to C. You've got the distances here, 60, 80, and 139. We want to describe the bearing from B to C. So we're going to need this angle in here, angle B. So let's go ahead and use the law of cosines to figure that out. So 139 squared, that's our little b over here. 60 squared plus 80 squared minus 2 times those. And then, of course, the cosine of big B, angle B. And so that's going to be, let's find out, 139 squared minus 60 squared minus 80 squared divided by negative 2. Let's put this in parentheses. Negative 2 times 60 times 80. And we get that. And so we'll do the inverse cosine of that. Negative 0.9709. And we get 166.14 degrees. 166.14, we'll just call it 166 for our purposes here. All right, so our job, though, is to figure out the bearing. And remember that the bearing, if we go straight from north and rotate over to this line, sorry, I went too far, over to this line right here. What angle is that going to be? And it's not going to be half of 66. Can't split it in half, okay? But we do know this angle right here, because that's going to be 166 taken away from 180, because that's a straight line there. So the remaining value is 14. So this little piece is 14 degrees, which means that this piece up here would be 90 minus that. 90 minus 14 is 76. And so our bearing is going to be north, 76 degrees east. Or just a bearing of 76. Because bearing, if you don't put anything, implies north and east. All right, your turn with some bearing. Let's see if you can sort out the bearing in problem 49. All right, last section here, just one more problem here. We do have a new area formula. Here's the formula for the area of a triangle if you know all 3 sides. And the only new thing here is S. A, B, and C are the sides of the triangle. S is what we call the semi-perimeter, okay? And that's the perimeter, A plus B plus C, cut in half. That's where semi comes from. All right, so the semi-perimeter is S. Figure that out first, and then you're just plugging in S times S minus A, S minus B, S minus C. Let's give it a shot here. Let's find the area of this triangle, 43, 53, and 72. First, we need the semi-perimeter. Add them up. 43 plus 53, that's 96, plus 72 is 168, divided by 2 is going to be 84. So then we're going to say the area equals the square root of S times S minus A times S minus B times S minus C. All right, so we're going to have the square root of 84 times 41 times 31 times 12, and to the calculator we go. 84 times 41 times 31 times 12 is 1,281,168. Gonna need the square root of that, so our area is 1,131. Your turn, bring it on home. Find the area of this parcel, and you're done there. We're done with 6-2, law of cosines. Questions, make sure you're asking them in class.